Hello and welcome back. Since we have estimated the moment of inertia about the x in the last lecture, we will be able to estimate the radius of gyration by saying that k of x equal to the square root of ix divided by a. Our a equal to bh for the rectangle, where b is the breadth, h is the height. The moment of inertia about the CG is bh cubed over 12. So kx equal to, we open one bracket, we are writing bh cubed over 12, all divided by bh, which is the area. Inside the brackets we raise it to the power of 1/2. b will go with b and h will take one of the h. So we left with h squared over 12 raised to the power of 1/2, which means that kx at the end equal to h over 2 multiplied by square root of 3. Now our next step is how to estimate the moment of inertia about y for the CG. The moment of inertia for the rectangular section at y-axis passing by the CG, by the first method, which is parallel axis theory, we are going to introduce our strip. Again, we have the external two axes x and y, and we have xg and yg passing by the CG, which is apart by b over 2 and h over 2 above the corner. For the area of the strip, the width is dx and the height equal to h. The moment of inertia about the y, which is external vertical axis, equal to the integration from x equal to 0, the strip as if it starts from x equal to 0, and it will end at x equal to b. But this time we are going to multiply the area, or the dA, by the x squared. And since the dA equal to dx by h, then inside the integration sign we are going to write dx multiplied by h, all multiplied by the x squared. H being constant, then we are going to perform, it will come out, we will integrate from x equal to 0 to x equal to b of x squared dx, which will give us x cubed over 3, all multiplied by h. But we are going to say that x start point x equal to 0, end point x equal to b. So the Iy will be equal to h over 3 multiplied by b cubed minus 0. At the end it will give us hb cubed over 3. If we are going to estimate, if we want to estimate the moment of inertia about xg, then by using the parallel axis theory, we are going to deduct the previous value. We will deduct from it the multiplication of the area by the y squared, sorry, by the x squared, x bar square. X bar square is b over 2. So our Iyg equal to hb cubed over 3, this is the value, minus the area, which is h by b, multiplied by b over 2 all squared. At the end we have hb cubed over 12. Since we have estimated the Iyg, we can get to estimate the radius of gyration. But first, as we have done in the previous Ix, we are going to use the second method. Second method is directly estimate the moment of inertia about yg. Our strip this time will be apart by x horizontal distance. The same strip width is dx and the height is h. But our x value starting of the integration will start from minus b over 2 to plus b over 2. Then Iyg at the center of gravity, center of, equal to the integration from minus b over 2 to b plus to b over 2 of the multiplication of dA, which is equal to dx by h, multiplied by square root, multiplied by the power of x, power of 2, x squared. H being constant will come out. Then we have the integration side x squared dx, which will give us x cubed over 3 inside bracket. And we start our starting point from x equal to minus b over 2 to x plus b over 2. Then IYG equal to h over 3 will come out, but being the upper bound is x cubed equal to b over 2 all cubed, which will give us b cubed over 8 multiplied by 3, it will become 24. Then if we get 3 out, then we have a new bracket b cubed over 8 minus, and inside another bracket small one, minus b cubed over 8. Minus multiplied by minus will give us plus sign. So we have h over 3 multiplied by 2b cubed over 8, which is hb cubed over 12, the same result which we have obtained using the parallel axis theory. We move to the radius of gyration. The radius of gyration in the y-axis, kg of y equal to the square root of iy over the area. Square root, the I is hb cubed over 12, and the area being bh will become in the numerator, all under the square root. So this h will go with h and 1b goes with 1b. We left with b squared over 12 under the square root. Then we have b over 2 multiplied by square root of 3. Thanks a lot. Our next topic will be the product of inertia for the rectangular section. Thanks a lot and see you. Goodbye.